Ángel la ciencia.
Our sun's steady heat and light makes life on Earth possible. But instruments operating above our atmosphere see a more dynamic star. Magnetic activity associated with sunspots can fire off torrents of high-energy radiation and launch billion-ton clouds of plasma, called coronal mass ejections, into space. NASA's Fermi Gamma Ray Space Telescope orbits Earth and monitors the entire sky for gamma rays, the highest energy light there is. Most of the time, the sun is merely a faint source of gamma rays, which are produced when high-energy particles called cosmic rays interact with either its surface gas or its lower energy light. Occasionally, tangled magnetic fields near sunspots suddenly release their pent-up energy. This produces an explosion that rapidly accelerates charged particles to near the speed of light. Confined by magnetic fields, some of these particles flow back toward the sun and excite gamma-ray emission. Suddenly, the sun may become the brightest object in Fermi's sky. Now, scientists say Fermi has caught gamma rays from solar storms located on the opposite side of the sun, where the spacecraft shouldn't be able to see them at all. Here's one of them. NASA's Stereo B spacecraft has a clear view of the solar flare, but the eruption cannot be seen by NASA's Solar Dynamics Observatory, which views the sun from the same direction as Earth and Fermi. Yet Fermi's Large Area Telescope detected gamma rays associated with this flare for nearly 2 hours. Here's what's going on. Magnetic field lines extend high above each active region on the sun, and charged particles must travel along them. Some particles accelerated at the leading edge of a coronal mass ejection can follow these lines and strike the opposite side of the sun, traveling about 300,000 miles in less than 5 minutes. So far, Fermi has observed 2 additional far-side flares, doubling the number of these rare detections. These observations will help scientists better understand how particles accelerate, travel, and interact to produce gamma rays during solar storms.
You may not have felt it, but all around you here today, a kind of missive from the sun. Our sun, 93 million miles away, after a massive eruption on the sun's surface, the most powerful waves of radiation in almost 9 years arrived here on Earth, traveling at a speed of 5 million miles per hour. Delta Airlines redirected half a dozen planes that would otherwise have flown over the North Pole because no one's sure if solar flares can interrupt a plane's communication and expose passengers to excessive radiation, though there's still no real risk to humans on the ground.
The big story is the CME that erupted with it, the coronal mass ejection, which you should see rippling through the sun's atmosphere after the eruption. The coronagraphs clearly show a halo eruption. Expansion on all sides here confirms the blast is heading at Earth. And normally, we would look at the C7 flare rating and CME characteristics and guess that it would spark a minor geomagnetic storm when it impacted tomorrow night, KP5. However, the CME is not coming alone. Stripped of CMEs on the endless spiral, we see the magnetic sectors of the solar wind, and the one due up next for Earth is apparently a dense one. The first powerhouse coronal hole stream of the solar cycle. Perfect timing, eh? A 1-2 punch, going from a climb out of sunspot minimum to a coronal hole in CME back to back. If we get that double tap, and the CME is south-pointing magnetic angle, we could see strong storms in the KP7 or 8 range. Even then, this is not an end scenario. Meteorological effects are likely, along with increases in electrical fires and large system glitches like in airline systems, PlayStation network, communications, or rail networks. Going to be a fun week.
The Mayans were right after all, just a few years off. There's a 1 in 8 chance the Earth may be hit with a catastrophic solar storm by the year 2020, according to a new report from space physicists. The sun changes in intensity on an 11-year cycle, and at its high intensity can propel charged particles into space at 4 million miles per hour, hitting the Earth's atmosphere and creating glowing ribbons of light known as auroras. Such light shows can wreak havoc on electrical systems, cause radio blackouts, and more. The last such storm in 1859, known as the Carrington event, set fire to telegraph stations. Researchers estimate a new event could cause $2 trillion in damages, paralyze electrical grids, disrupt GPS systems and radio communications, and require a decade's worth of repairs. Paging John Cusack and Nick Cage. Better get this disaster movie in production. Theaters may not have the juice to play it after the fact.